Okay, hello everyone. Okay, today we will start with linear regression problems. Mhm. And if we got the input data set of the advertising.csv, that is a very popular and useful training data for the machine learning about the linear regression problems. This is um, our data. Here, this is the advertising.csv. You can download advertising.csv from the various sources on the internet, and I will talk about this downloadings later. Uh-huh. For the easy visualize the dataset, we will focus on the only one feature, uh-huh, and TV advertising, and only one output cell, right? The dataset are composed of three features. Our three feature is X1, the advertising on the TV, and X2, advertising on the radio, and last X1 feature, X3 feature. That is advertising on the newspapers. And our output here, Y, about the sale item. That we may call this is output. Okay, sorry. Output and maybe target. Okay, and our target or this is about the feature or input, right? Input feature. We have three feature. This is feature number 1, 2, and 3, right? Okay, and for the easy to visualize data, when we plot it, we will focus on just only the first column features and the last columns of the data output right here. And okay, the data set content of the feature that is the TV advertising that corresponding with the output or our tracker cell on the last columns. Look at the first columns. This is advertising. It's investment money. The units of the this column is multiplied by 1,000. Okay, US dollar. Okay, and the last one, the last column is the it is sale number of item of goods that sell more. The increase of the item when you spend the money on the advertising on TV. That the items, the unit of the item is also multiplied by 1,000. Okay. Okay. And if we scatter plot the data set that show on the this picture, the vertical axis is a cell or our output Y, right? This is Y, right? Or our sales item. Okay, our cell item. And the X input here, this is our advertising, investment money, like on the TV advertising, right? Or we call X, right here, and we scatter plot like this. Okay, we and we fit the data with the linear equation. The parameter of the equation of the linear equation is a slope and the intersection of the point on the y-axis when the x is 0. Okay, we may let's say our linear equation like this to fix the data, right? And if you write the equation, maybe y equal to m, that is our slope, and x input, and plus by c, that is the intersection of the y-axis when x equal to 0, right? And if we rewrite it in our hypothesis function that we talked about this in the first video, right? The hypothesis function, right? Maybe like this. Our hypothesis function, the function of the theta, right? On the x, and equal to the slope. We say theta 1 x and plus theta 0. This is our hypothesis of our model, right? This. Okay, we may say the hypothesis of our models, and you notice it. This is our error, right? This is our error. The error is a vertical distance from the data point to our models or our hypothesis. This is a with error because this is impossible to fix every point of data, right? And we try to represent the trend of data by this equation, the equation, right? Okay. And that means I want to know what our parameter theta that give us the minimi of error, minimi of this error, because we want to find the equation that the best describe or the best represent our data. I want to know maybe this is or this. Okay, and then what does that mean? We try to find the theta that give us the minimi of errors from the model and our data, right? Okay. And this is a various way to measure the errors from the big data like this. And in this class, we will use mean square of error, right? Okay, mean square error. Errors. Okay, the mean square error is equal to one divided by a number of the data and the summation of i's equal 1 to n, and our hypothesis function of our models, right? X minus by y I, okay, lower skip I and square like this. This is means that is a means of a square of error, and we try to minimize this function. Okay, we may call this is a error function. This is the error function. We try to minimize the error. Okay, we may write it into the minimize form like this. The minimize theta zeros and theta 1 by the square of error of summation of the I 1 to n and to n, and hypothesis x, and that's y by, okay, superscript I, and okay, this is, we try to minimize this. Okay, I I prefer to divide by 2 here. Actually, I can divide by anything because that is a relative comparison, because every point of data divides by the same value, and I should divide by 2. The reason that I divide by 2 because when I take the derivative on this term, the 2 will be cancelled. Okay, but I divide by 2, and we may call this function is our cost function. The other function is a cost function. We may say this is the function of the theta, right? The cost function and our hypothesis function is not the same. The hypothesis function here, this is a function of x, right? Whilst the cost function is a function of the theta. This is not the same thing. Okay. And this is a very nice way to solve the problems. And in this class, we will use the gradient descent and all the steepest descent. This is the same things. The gradient descent, or maybe call the steepest descent too. Okay, maybe call the steepest. Okay, I will give you the iterative function, iterative algorithm to solve the problems. And here, this is a theta vector, k plus 1, the iterative. This is a iterative algorithm, right? So that is k, and the negative of the learning rate, right? This is a learning rate, and partial differentiative of the thetas and the cost function, partial derivative of the cost function. Okay. So once here, this is our fixed or constant learning rate, right? Okay, you fix it, and the theta is the column vectors. So 0 and theta 1. Okay, like this. If we do the iterative calculation, the theta will be minimized. The function of our cost function here. That make our cost function is when we take a different differentiative like this, this is that's the point. This is we try to find the lowest point of the cost function, or the minimize of the cost function here. If we use the learning rate is too small, we will take time. Use a last step. Use a lot of number of steps, and maybe waste time, consume a lot of time to go through the minimum points. Okay, if you use a too big of the learning rate, so too big. Okay. If we choose a too big, this is the learning that is we may overshoot problems. We don't match maybe don't find the minimum point. Okay, and the learning that should be appropriate. And okay, I I don't want to introduce you do it in the details because I want to skip to the a powerful tool to solve the problems. But otherwise, if you need to understand more about how to solve the problems, with the minimize problem, I highly recommend you about these two books. This is very, very useful and very great book. Um, on the right side, this is appropriate for the analytical methods, okay, for the optimization problems. And the left side, this is appropriate for the iterative methods. This is very useful. Okay, uh, you may you can learn it by yourself to make you more understand about this. And in this class, I will introduce you to the sorted equation by the MATLAB, right? Okay, I will switch to the our computers. Okay. Okay. Okay, everyone. Okay, I will find the. Sorry, I will find the advertising.csv by the typing in the Google's advertising.csv and more. But okay, this is very short and so on to download it, and you can download and see more explanation about it, the dataset. And I already did. I downloaded it already in my computer. Okay, and we use the MATLAB to solve the problems. Okay, the MATLAB built-in function. Okay, the first thing I will import the data from the advertising.csv home and import data. Go to the desktop and here. Okay, and this is okay. Double click it. This is be careful when you import that. We should use the column vector here. Okay, and use select only the data. What happened? Sorry. Okay. I just already select this and import it. Okay, imported already the data here. Okay, you may see this, and we will use only one feature. Okay, that's it. This is the way to scratch the code. The part about our input T3 and output cell. Okay. And enter. Okay, we got the scatter plot, and this is it where you can do the same thing in this in the Excel, right? True, and basic fit. Okay, this is basic fit. Oh, okay, right. You can fit the models like a linear. Okay, and show the equation here. Notice that the equation, that the parameter of the equation here. Okay, 0.048, right, and 7. And this is our theta, right? And we you can use more the sophisticated equation, just like the quadratics, cubics, or maybe the 4 degree of the polynomial, like this. Okay, it's not good. Okay, and okay, we will plot the residuals. Maybe here. Maybe not in bar plot, but in the scatter plot, like this. Okay, and I will show the residuals. Okay, if you know that is in the residuals, the base fit is maybe the 4 degree of the 4 degree equation. Okay, this is a very easy way to use. Okay, I will introduce you the. You should remember this. Okay. I should introduce you the another MATLAB routine function, just like this. A equal to fit linear models and x input t, v and cells. Okay, and they identify the other parameter. That is the same parameters. Okay, and give out the r square, give out the how the measure for this. This is for grad fit. Okay. Okay, we will back into the our screen. Okay, we can solve this problem by the MATLAB routine function. This is a very easiest way to do this. Okay. Oh, okay. And okay. Okay. Okay, we're back here. For our assignment 1, okay, for our assignment 1, why the linear regression still work? Okay, why? The question is why we don't use more sophisticated or more complex equation to fit our data, just like high degree of the polynomials equation, maybe exponential equation. Why we don't use that? Why the linear equation is still work for machine learnings? Okay, I want you explain more about the issue and show you the understanding about the problems, right? This picture actually that is your answer, but I need to understand more about this. Okay, I need to explain more about this issue, right? Okay, the answer here in this picture. Okay, for the for next video, we will deal with multi-feature and using the anaconda. Okay, see you on the next video.